Okay, students. So in the previous class, we have seen the two basic fundamental rules of laws of indices. So now let us go for the third rule. Clear? So that is a power m whole to the power of n plus again a power m whole to the power of n will be equal to, that is, a power mn plus a power mn. Clear? So this is a very basic fundamental rule where you don't need a proof for this. That is, m and n has to be multiplied. Here m and n has to be multiplied. Clear? This will be a to the power of mn plus a to the power of mn. So it can be written as 2 times of a to the power of mn. No problem. Clear? Also see this, a to the power of p whole to the power of q plus a to the power of p or a to the power of r whole to the power of s can be written as a to the power of pq plus a to the power of rs. Clear, students? So these two terms are going to be multiplied. That is, p multiplied with q, r multiplied with s. Clear? That is what your third basic fundamental rule. Are you getting my point? So a to the power of m whole to the power of n plus a to the power of m whole to the power of n is equal to a to the power of mn plus a to the power of mn, that is equal to 2 times of a to the power of mn, and also a to the power of p whole to the power of q plus a to the power of r whole to the power of s will be equal to a to the power of pq plus a to the power of rs. Clear, students? So this is the third fundamental rule. Next, fourth one, that is a multiplied with b whole to the power of m can be written as a to the power of m multiplied with b to the power of m. This is also very basic fundamental rule. A is multiplied for m times, b is also multiplied for m times. Clear? So ab whole to the power of m can be written as a to the power of m multiplied with b to the power of m. Okay? So now fifth one, that is a by b whole to the power of m can be written as a to the power of m divided by b to the power of m. Clear, students? So some students will get confused with a to the power of m minus m. Here see, the bases are different. A is not equal to b. So I can't write like this. Please understand that. I can't write this. Why I can't write? Because b and a, they are the basis of exponential form where these two terms are not same. If these two terms are not same, I can't write a to the power of m minus m. Clear? So a to the power of m divided by b to the power of m, that is a by b whole to the power of m. Clear? So here you have totally 5 fundamental rules. That is, first one, a to the power of m multiplied with a to the power of n will be equal to a to the power of m plus n. Second one, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Clear? Next, third one, that is a to the power of p whole to the power of q plus a to the power of r whole to the power of s is equal to a to the power of pq plus a to the power of rs. Clear, students? Next, the fourth one is a to the power of ab whole to the power of m is equal to a to the power of m into b to the power of m. Clear? And the fifth one is a by b whole to the power of m. A by b whole to the power of m is equal to what? A to the power of m divided by b to the power of m. So these are the 5 basic fundamental rules of laws of indices. Please remember these things before you start mathematics, before you start physics, or before you start chemistry. These things are going to be come in every topics, mathematics, physics and chemistry. Clear? So please make a note of this, or please make a notes of this to understand these 5 fundamental rules. So make sure that these 5 fundamental rules are perfect to you. Clear? So next let us see some problems on this. Okay students, let us see example 1. Clear? Example 1 is a to the power of 0 equal to 1. We have to prove a to the power of 0 equal to 1. Clear? So let us see this. What I will do to prove this, I will multiply a to the power of n on both sides. That is multiplying a to the power of n on both sides. A to the power of n on both sides. What you are going to get? A to the power of 0 multiplied with a to the power of n, that will be equal to 1 multiplied with a to the power of n. Clear? So now what you are going to get? A to the power of, by using laws of indices, 0 plus n, this will be equal to a to the power of n. Clear? Next, what I can write this? See, a to the power of 0 plus n is nothing but what? It is equal to a to the power of n. That is LHS is equal to RHS. Clear? So from this what you can understand? See, a to the power of 0 is multiplied with one of the number, that is a to the power of n. See, a to the power of 0 is multiplied with one of the number a to the power of n. Again it is giving me a to the power of n. Are you getting my point? See, I have multiplied two numbers, that is a to the power of 0 multiplied with a to the power of n. Output I am getting again a to the power of n. So whenever you multiply any number with other number, see, I will multiply a to the power of n with any number, output I am getting a to the power of n. This is a very common sense. In this box there must be 1. In this box there must be 1. Clear? So in the same way, see here, I have a to the power of n. I have box, I am getting a to the power of n. I am getting output as a to the power of n. That means what is my meaning of this box? This box must be equal to what? 1. Clear? So therefore we can say that a to the power of 0 is equal to 1. Are you clear? I am proving that a to the power of 0 is equal to 1. Clear? To prove a to the power of 0 is equal to 1, it's a very basic thing, that is a to the power of 0. For a to the power of 0, I am multiplying a to the power of n on both sides. If I multiply a to the power of n on both sides, it can be written as a to the power of 0 plus n. A to the power of 0 plus n will be again going to be equal to a to the power of n. So that LHS is equal to RHS. LHS is equal to RHS. Suppose if you get confused, you remove this. If you remove this step, don't multiply a to the power of n on both sides. Don't multiply a to the power of n on both sides. I will remove it. If you get confused, I am telling it. If you get confused, see another proof. See another proof. That is, I will take a to the power of 0. To this a to the power of 0, I will multiply a to the power of n. Now what you are going to have? You are going to have a to the power of 0 plus n. You are going to have a to the power of 0 plus n by the laws of indices. So now this is going to be equal to what? A to the power of n. Clear? So from where you started, by multiplying a to the power of n to a to the power of 0 you have started. As we all know, for any number a to the power of n, if we multiply this box, if we are getting a to the power of n, for any number a to the power of n, multiplying this box, if we are getting a to the power of n, there is a common sense, that is, in this box it must be 1. That means a to the power of n multiplied with 1 will give us a to the power of n. Clear? So see here, a to the power of n multiplied with this box, I am getting a to the power of n. That means in this box what you must have? You must have 1. That means a to the power of 0 is equal to 1. A to the power of 0 is equal to 1. Clear students? Okay. Now let us move for the next example. Okay students. Now let us go for the second example. That is a to the power of 1 by 2 multiplied with a to the power of 1 by 2. Clear? So if I simplify this by using the laws of indices, what you are going to write? A to the power of 1 by 2 plus 1 by 2. Clear? So what is 1 by 2 plus 1 by 2? That is a to the power of 2 by 2, that is nothing but equal to a to the power of 1. Again you can write it as a. Clear? So a to the power of 1 by 2 multiplied with a to the power of 1 by 2, that is nothing but a to the power of 1 by 2 plus 1 by 2. A to the power of 2 by 2, that is nothing but a to the power of 1, that is nothing but a. Very simple problem, very basics. Clear? So by using the laws of indices, we can understand that multiplication of these two will be equal to a. Here I want to tell you one important thing. This a to the power of 1 by 2 means it is nothing but root a. Clear? Into a to the power of again 1 by 2 means that is nothing but root a. If you multiply two roots together, it will be equal to independent of root. Clear? That means root a multiplied with root a will be equal to a. Are you clear? So this is something important because some of the students will be getting confusion between a to the power of 1 by 2. How can you write a to the power of 1 by 2? A to the power of 1 by 2 can be written as root a. Here also again a to the power of 1 by 2 can be written as root a. Clear? So now with this, see example 3. What I will do? I will write a to the power of 3 by 2 multiplied with a to the power of 5 by 2. Clear? I will write a to the power of 3 by 2 multiplied with a to the power of 5 by 2. Now what you are going to get? See this. This will be equal to, by using the laws of indices, a to the power of 3 plus 5 divided by 2. Clear? So if I make this simplification, 3 plus 5 is 8 by 2. 8 by 2 will be equal to a to the power of 4. Are you getting my point, students? So this can be written as what? See, this can be written as cube root of a. This can be written as fifth root of a. Clear? So now this will be equal to a to the power of 4. A to the power of 4. Clear, students? So please understand that a to the power of 1 by 2 can be written as root of a. Here a to the power of 1 by 2 can be written as root a. Root a into root a will be a. A to the power of 3 by 2 is 3 root, that means cube root of a. Clear? This is fifth root of a. Clear? That means 5 by 2 can be written as fifth root of a. 3 by 2 can be written as cube root of a. Clear? So therefore that is a to the power of 3 by 2 multiplied with a to the power of 5 by 2 will be equal to a to the power of 4. A to the power of 4. Clear? Okay. Let us go for the next problems.